All right, let's go ahead and start Chapter 10. The next test is on Chapters 8 through 10, so when we finish 10, we'll have the test. That's all I can tell you. I don't know when that's going to be. But right now, my best guess would be that for this class, today's Monday the 4th, we won't finish Chapter 10 today. Hopefully, we'll finish Chapter 10 this week on Thursday. Then we could have the test a week from today on the 11th. Okay? That's my best guess. Maybe we'll try and squeeze some lecture time in Wednesday. That might help. Okay, in this chapter, Chapter 10 now takes us to energy changes in chemical reactions. We've gotten used to writing chemical equations, looking at the balanced equations to deal with some stoichiometry, and now we're going to go ahead and look at how the energy changes, and then by the end of this chapter, we should be able to calculate information about energy and combine that with stoichiometry to do some really fancy sort of calculations. This is the homework that I assigned from the book. And I'd like to remind you, this is not a suggestion. This is your assigned homework that I expect you to do. And if you do it and practice, you should be very ready to take the test. It's not optional. Sometimes my students will tell me at the end of the semester, gee, I wish you had assigned more homework. Well, there's plenty of it there, and there's extra I don't assign. But I find a lot of my students don't do it. So these are your definitions. Again, I expect that you've read this ahead of time and gone through your book and filled this in so that you will be able to understand the vocabulary in this chapter. So in this chapter, we talk about energy. So we'll start with a definition of energy. In chemistry, we use the joule to determine energy. And this is spelled Joule for the scientist who discovered this. This is not joule like emeralds and rubies. It's not Jewel. Okay, it is the unit of energy, and it is defined as the energy required or produced when a 2-kilogram object moves at a rate of 1 meter per second. So a joule is defined as a kilogram meter squared per second squared. And we looked at this previously when we talked about kinetic energy earlier this semester. Remember, kinetic energy was 1/2 times the mass times the velocity squared. And if the mass is in kilograms and the velocity is in meters per second, we get kilograms meters squared per second squared when we square the velocity. So that's where the joule comes from. Now, we also have the English definition of energy, which is a calorie. And the calorie is the amount of energy required to raise 1 gram of water 1 degree Celsius. So when we try and compare the joule, the metric system, to the English, 4.184 joules is 1 calorie. And that is a very, very small amount of energy. Think about 1 gram of water heating up 1 degree C. It doesn't take a lot of energy. When we think of calories in our everyday life, they're not really calories by this definition. The nutritional calorie, that there's 300 calories in the candy bar, that is actually, for us, the kilocalorie. That's 1,000 of these calories. Sometimes the nutritionists call them big calories, and they use the uppercase C. But we don't call them that. We call them a kcal. Okay, so the first one, how many calories are in 723.01 joules? Well, changing calories, we have 723.01 joules. And we know by our definition that 1 calorie is equal to 4.184 joules. So that would be 172.8 calories. We would keep the 4 significant figures. Okay, go ahead and do the next one just at your seats. Just take a moment and do this one at your seats.